Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. What we're going to see first is how to make a sphere of water. And this is a sphere that's going to be attached to a wire frame so that you can hold it stationary in front of your camera and you can do experiments on it without it drifting into the wall. So the easiest way to make a sphere is to first start out with a water film, and we've seen how you make the water films. And what you do is you add more water to a film and you just inflate it into a sphere. And here you see the straw from a drink bag being used to inflate a water film into a sphere. And this is by far the easiest way to make a sphere that's attached to a wire loop. And you can keep adding water until the wire frame makes the diameter hoop of this sphere, and it tends to hold it nice and stable. Here is another way to make a sphere, and that's where you just basically start to inject a big blob of water into one of these loops. And you can do it this way, but it's a rather tenuous situation where you start to get this larger and larger blob of water, but it's not quite locked into the loop, and it's real easy to lose it. But you can see once the diameter hoop is locked in on this sphere, that sphere isn't going anywhere. It's stationary. So that's another way of making one of these spheres is to just inject it in the loop in the first place. And here you can see a water sphere, a little shot off to the side, showing that it makes a pretty nice magnifying glass just in itself. And you can also see a little cutaway in the wet chemistry lab where we're working in the FGABE. The third way to make a water sphere is shown here, where you have this free sphere of water, and you just make it so that you can lasso it with your wire loop, which you just saw happen there. And again, once you lock a sphere in to its diameter cord in one of these loops, it is there to stay. It's not going to go anywhere. Now, once you make one of these spheres, you can remove the water from the sphere by just sticking a towel on it, as you see here, where a towel goes up into one of the spheres, and you can selectively draw water off to make the sphere smaller if you want to. And you can end up making one of these lensical-shaped structures, where you have something less than a sphere, and it makes a nice magnifying glass. And I think you could call that a meniscus lens. So now that you've got your spheres made, let's see what we can do with the spheres. And let's look at what happens when you introduce a drop of liquid into a sphere. And here you can see we have a syringe filled with tracer particles, and on a little droplet of these tracer particles squeezed out on the end of one of these Teflon cannula. And what we're going to do is just touch that little droplet against one of these spheres. So what do you think is going to happen when you introduce a little droplet of these tracer particles into a sphere? What kind of mixing is going to happen? Are the particles just going to go everywhere? What's going to happen? And this was something that before I did the experiment, I had no real idea what was going to happen. And when I saw what actually happened, it just made my jaw drop. So let's see if this makes your jaw drop. Let's watch the video now and see what happens when this little droplet of tracer particles gets introduced into the sphere. Wow, look at that. Would you ever believe that it would make a vortex ring? Look at that. We're going to see this over and over again. Little droplets of tracer particles being introduced across the sphere, the interface of the sphere, and they make these vortex rings. And they'll shoot across the full diameter of the sphere. If they have enough energy, sometimes they'll stop in the middle. And here we see these vortex rings being generated from the backside. And notice you have the little tiny drop of tracer particles. As it touches the side of the sphere, it gets sucked into the sphere, and you can actually shoot a vortex ring through a pre-existing vortex ring, as we saw in that last case. So what's happening here? Why do we get these little vortex rings forming? It's really fascinating surface chemistry going on here. And I'll leave it as an exercise to the student to try to figure out what's happening. Now here we see another example of introducing fluid into a sphere, but this time the tip of the cannula has been embedded inside of the sphere, and we're slowly injecting fluid into the sphere. And notice that it just looks like a standard smoke going out of a smokestack. So there's something really interesting that happens when you inject water into a sphere through the interface as a small droplet, as opposed to just sticking a tube inside of the sphere and injecting fluid in the sphere that way. Really neat stuff. And you can end up making one of these lensical shaped structures where you have something less than a sphere, and it makes a nice magnifying glass. And I think you could call that a meniscus lens. Wow, look at that. Would you ever believe that it would make a vortex ring?
And Houston Alpha, that's it for our Saturday morning science.